Hello, everybody. Mr. Garrick here. Jumping into lesson 4. So last lesson, and I'm going to jump right in and I'll go back to the learning targets here in a second. Last lesson, we learned how to multiply a monomial, right, into a polynomial. Today, we are going to be multiplying two binomials together. So you can see the learning target, multiply a binomial by a binomial. And also, we're going to do a binomial times a trinomial. All right, so moving up in the world a little bit here. So you can see what two binomials looks like right here. First example, 2x plus 3 times x plus 4. One thing I really want to point out early on here, there's no symbol in between those. That indicates multiplication. I have people who will add stuff here. There's no plus between the binomials. That means we're multiplying them. All right, moving on. To do this, to multiply these two binomials, we need to multiply each part of the first binomial, which if you didn't catch it is 2x plus 3, by each part of the second binomial, which is x plus 4. Well, each of those binomials by name has two parts. That means if we're multiplying everything together, we're actually multiplying 4 things together. All right, I'm going to show you 2 ways to do this. I'm going to do number 1. I'm going to show you both of them, but I will do in class number 1. All right. And method number 1, kind of one of the big things that comes from algebra 1 is learning how to FOIL. You've probably heard it before. Maybe you haven't. But if you have, this is what we're doing. Okay. FOIL is an acronym, which means each letter stands for something. I'm going to talk about that in a little bit. It's an acronym that represents a shortcut for multiplying. Okay, or a process. Okay, it's a shortcut, or you could almost think of it as like a process for multiplying. Okay, it only works when you are multiplying two binomials. And here's why that's true. If it's an acronym, you've got each letter standing for something. There's 4 letters. We're multiplying 4 things together when we're doing a binomial times a binomial. That's why FOIL works only with 2 binomials. If I have a binomial and a trinomial, I now have 2 things and then 3 things. I'm going to be multiplying 6 things together. It doesn't work. Okay, now we're going to talk about what each letter stands for. F stands for the first terms in your binomials. So I know I've scrolled, so I'm going to rewrite the 2 binomials here. So 2x plus 3, x plus 4. So if I'm looking at these 2 binomials, the first terms in each binomial are 2x and x. Okay. The O stands for the outer terms. You know what I'm going to do? I'm going to go a different color here. So O is your outer terms. These can be a little confusing, which ones are the outer terms. But if you're looking at the binomials, the ones on the farthest outside, so that would be 2x and 4. They're on the outside of the binomial, far left and far right. So the outer terms are 2x and 4. You might be able to guess what the next one would be. The I stands for the inner terms, which are basically the opposite of the outer. So that would be 3 and x. Okay. Last one, just kind of said it. L stands for the last terms. And we're talking the last terms in the binomials. So 3 times 4. Okay. And you can see I use different colors, and each term has 2 lines underneath it. It's a different combination of colors, which is good. It means we're multiplying each term by the other binomial. Okay. Now, I kind of have referenced it a couple times. Switch back to blue here. The first step is to multiply each of those pairs of terms together. All right. So I'm going to go ahead and do that. 2x times x. Remember, when you multiply, the exponents can change. So that's 2x to the first, x to the first. That's going to be 2x squared. Okay. The outer terms, 2x times 4. That's just 8x. 3 times x is just 3x. And then 3 times 4, 12. All right. Now, that's only the first step, is to multiply. The second step is to add those like terms together, if there's any like terms. And you're going to notice, as we do a lot of these, that a lot of times the middle two terms can combine by addition. So 8x plus 3x makes 11x. And now I'm just going to write this as all the terms added or subtracted together. So 2x squared, 11x is positive, and 12 is positive. And that's your product. So notice, two binomials turns into, a lot of times, a quadratic trinomial. A lot of times that's going to be the case. All right, moving down, the second method, which some people that are more visual like this one better. I don't, because it takes time to get it set up. Another thing that's kind of nice about this one, though, is you've seen it before. I think you've seen it before in your bio class. If you've gotten to Punnett squares in biology, it's kind of like that. This method might provide a better visual, but gives the same answer as the previous method if it's done correctly. So basically, you're just filling in the Punnett square, 2x times x. You're just multiplying those. 2x times x is 2x squared. Then you're going to multiply 3 and x. 3 times x is 3x. Then you're going to multiply 2x and 4. That's 8x. And then you're going to multiply 3 and 4, which is 12. So the first step, again, just like with FOIL, was to multiply. Second step is to combine your like terms with addition or subtraction. And so I've got like terms here. You see that I have 2x squared, no other x squared. So I'm just going to write that. 3x and 8x, you add those. That makes 11x. And then the 12 stands alone. Get the same answer as you did with the first method. Okay. If you like that method, that's fine. You can do that. I'm not going to do that anymore on these notes. Okay. Once you're getting used to the FOIL method, it's quicker. Yeah. So we're going to do a couple more here. X plus 5 times x plus 2, or x minus 2. You're doing the first terms, x times x. You'll see this work done a lot in the next few weeks. Then I'm going to do x times 2, negative 2. And yes, that is a negative 2. Those are the outer terms. So that's negative 2x. Then you're going to go inner terms, 5 times x. That's 5x. And then the last terms. For some reason, people mess up on the last terms here. And a lot of times I will see people write 3. They'll do 5 minus 2 and say 3. We're multiplying. 5 times negative 2 is negative 10. Okay. Once you've multiplied, now we add our like terms. And those middle terms are like terms. So it's x squared. Negative 2x plus 5x is 3x. And negative 10 is there. Before I do the last one, the last one for foiling, understanding how to FOIL. If you understand how to FOIL or multiply binomials, you will have a lot better success when we get to lessons 6, 7, and 8. Because basically in 6, 7, and 8, what we're going to be doing is we're going to be unfoiling. We're going to go backwards. So we're going to start with something like this and go to something like that. So understanding how to FOIL will help you in that situation. So make sure you're paying attention here. All right, 3x times 2x. 3 times 2 is 6. X times x is x squared. Exponent does change. I shouldn't be writing on the line. I'm going to write it right here. Sorry. And now I'm going to do 3x times negative 1. That's negative 3x. Then I'm going to do negative 2 times 2x. That's negative 4x. And again, you're multiplying. Negative 2 times negative 1. That's positive 2. Combine those. Negative 3x and negative 4x makes negative 7x. 2 is positive, so plus 2. Okay. Kind of already referenced this earlier when I was talking about the learning targets, but multiplying a binomial by a trinomial, which of the two methods described on the first page, does not work here. FOIL does not work. FOIL only works with two binomials. So which method do we need to use? We're going to use the box here. I know I said I didn't like it as much. But there are times when you kind of have to use it. Okay. So we've got 6n minus 5 times 2n squared plus n plus 7. A little bit more advanced here. So what I'm going to do is I'm going to set up a box. But the box is not going to be a square. It's going to be a rectangle. Now, the way I set it up may not be the same way you set it up. You might set it up like this. And that would be fine. Either way is fine. What does matter, though, is where you line up your binomial and your trinomial. The binomial has to go on the side with 2 boxes, so 6n. And I'm going to make sure that's -5. So I'm going to put the negative there with it. That is important. Okay, so on the other rectangle, I'd have to put 6n here and -5 here. The trinomial goes on the side with 3 boxes. So 2n squared, n plus n. So you could put positive plus if you want. It's more important with the negatives, but there's no negatives with the trinomials. So, and then on the other rectangle, on the other rectangle, you need to put those on the left side this time. The first step is multiply. So 2n squared times 6n, that's 12 n to the third, right? I have 2 n's putting with 1 more n, so it's n to the third. 6n times n is 6n to the second, right? 6 times 1 is 6, n times n is n squared. 6n times 7 is 42n. -5 times 2n squared is -10 n squared. I'm not putting any more n's in, so it's just n squared. -5 times n is -5n. -5 times 7 is -35. Just to show you that it doesn't matter how you set it up, I'll multiply on the other side too. You'll see you'll get the same thing. 12n squared, -10 or -12n to the third, -10n squared, 6n squared, -5n, 42n, and -35. You'll see that all of those numbers match the other rectangle. Okay, so I'm just going to focus now on the rectangle on the left. I now need to combine like terms. N to the third, there's no other n to the third, so I can just write that on the line. 12n to the third. I have 2n squareds. Remember how to do this. We're adding these, right? -10n squared plus 6n squared would be -4. Exponent doesn't change now. N squared. 42n and -5n. That's 42 plus -5. That's +37n. And there's no other 35 or constant, so it's just -35. Okay, and there's your answer. Notice it's 4 terms. It's very common with a binomial times a trinomial, but there you go. Last thing before I move on, notice how the like terms in a box are almost always diagonal from each other. Okay, that's going to be the case if you do the box, you're going to be diagonal from each other. If they're not diagonal, you're probably doing something wrong. All right. Last problem looks awful, kind of is awful, I'll be honest with you, but is not going away. It will be here for the rest of the semester. I'm not kidding. There is a question like this on the final. I already know that. Okay. It says find the area of the shaded region. Well, the shaded region is the green part, right? Finding the area of a rectangle is not hard. It's just length times width. So in this case, it's just 3x plus 2 times 2x minus 1, which would be fine and dandy, right? You could do that if there weren't that white box in the middle. So what we need to do is we need to take the area of that white box and subtract it. So we need to subtract, I'm going to try this again. More space. So 3x plus 2 times 2x minus 1. On the other side, I got x plus 3 and x minus 1. That's the area of the white rectangle. And to find the area of the green, I'm going to do the area of the whole rectangle, which is this one, minus the area of the white rectangle, which is this one. That's going to be the green. So I'm going to give you a tip here that I would highly recommend you follow. I'm going to separate this into 2 problems with the subtraction sign in between it. So I am just going to FOIL twice. Okay, 3x times 2x is 6x squared. 3x times -1 is -3x. 2 times 2x is 4x. And 2 times -1 is -2. Combine those like terms, I get 6x squared. -3 plus 4 is 1, so I'm just going to put 1x or just x minus 2. That's the area of the whole rectangle. Now the area of the white rectangle. X times x is x squared. X times -1 is -x. 3 times x is 3x. And then 3 times -1 is -3. Combine the middle terms, I get x squared minus x, plus 2x. -x plus 3x is 2x minus 3. Now we're not done. Now we need to subtract those two. This goes directly back to lesson 2. So I've got a polynomial minus another polynomial. Do you remember what we did with this? We changed this to plus and distributed a -1, right? Which changed the sign in the second one. So we're going to have 6x squared plus x minus 2 plus -x squared, -2x, and +3. Now I'm just going to combine my like terms. 6x squared plus -x squared is 5x squared. X minus 2x is -1x. And then -2 plus 3 is +1. There's your final answer. A lot of work involved, but nothing new. All right. Okay, I believe that is it. We are going to do another lesson on this tomorrow, but like I said, this is very important. Make sure you understand it, okay?